Hello. Today we are going to be looking at the notes over 20.1, which is our connecting intercepts and zeros. And we're going to first look at this graph of a parabola and talk about some of the different characteristics of a parabola and identify what these lines are going to. So I think the easiest one that we've talked about kind of since the beginning of this unit is this point down here at the very bottom. And hopefully at this point you guys know that that is going to be my vertex. In this case, your vertex is always an X and a Y value. It's a point. The other thing that we've talked about, and I know I've answered several questions on this, is that this is that invisible line, that dotted line that's going there. It's actually invisible, but we put it in there so you can see it, is that that is our axis of symmetry. Our axis of symmetry is a vertical line, and in this case, it would always be the line x equals whatever the x number is from this vertex point down here at the bottom. Okay. And so then we have these other couple points that we see these arrows to and going on my graph. So here, that first one there, right above axis of symmetry at -6, remember that this is my y-axis. So we talked about this in terms of lines, but now we're talking about it in terms of parabolas, and that would be my y-intercept. Not intercepts, just intercept. It will always be the value 0, and then it'll be a y value, but your x will always be 0 there at your y-intercept. And then those new 2 points up there at the top that we're talking about. In this case, because they are crossing your x-axis, those are our x-intercepts. But they also have some other special names. So that's an x-intercept. This one over here is also an x-intercept as well. But like I just mentioned, they also have special names. And in this case, their other names that you will hear them referred to are the zeros, the roots, or the solutions. Okay. So in this case, because it's an x-intercept, it will be always x comma 0. So if they're asking you to find the solutions or the roots or the zeros, it's always whatever the x value. So in this case, for this parabola, the solutions here, that's at -2, -3, -4 here. Oops, sorry guys, I'm kind of, if I look at my units here, they're actually going by a half. So here would be at -1, there's -2. So here that 0 is at -3. This 0, if that's half, this is where x is equal to 1. And there would be where my two solutions are for that parabola. Again, it's knowing that vocabulary. In this case, on the state test, they could also say, what are the zeros of the function? Well, my zeros would be at x equals -3 and at x equals 1. They could say, what are your roots? They could ask you, what are the solutions? So any of these four things are all asking the same question, really. And there's our definition of a zero. The zeros of a function are the x values that make the function value 0, which is this is where I'm actually asking when y is going to be 0. They are the x-intercepts of the graph. Okay, and there's your reminder from when we did them in lines that our x-intercepts are the places where the graph crosses the x-axis. The zeros of the function, and I kind of just talked about them up there, my zeros of the functions are the solutions of my original equation. So if I think about a parabola, that U-shaped graph, I would ask yourself, kind of think to yourself, how many times could that parabola, could that U cross my x-axis? Well, the one we just saw up here above, we saw that it was crossing in two places. We saw it was crossing here, and we saw it was crossing here. Do you think every parabola has to cross in two places? Okay. In this case, so we know that quadratic functions can have two zeros. How many does it always have to be two though? And the answer is no. It could also have one, or it could have no zeros. And if you look at these graphs that I have down here below, this first one is where you're saying, okay, there's my two. So this one has two zeros, two solutions. Whereas here in the middle, again, I'm asking where is it crossing this x-axis? And that parabola is not touching, it's not crossing that x-axis at all. And so in this case, this one has 1, 0. Oh gosh, I'm sorry guys, I'm jumping ahead. I was trying to, this one has no zeros. Okay. And finally, that last one, because this parabola is coming down, it's just touching the x-axis and going back up. This one only has 1, 0. Okay, so there's three different possibilities with quadratics for how many answers or solutions there are. So if I wanted to solve a quadratic, if it asks you to solve and figure out what x is equal to, first of all, I want to rewrite the equation so that it equals 0 on one side. Some of these are not equal to 0. Um, and then I'm going to replace the 0 with a y. And graph the function. And again, I've asked this question a lot, but hopefully you do this, is that where do we go to graph? And in this case, I hope you answered to yourself, we go to Desmos. Desmos is our best friend here with graphing. Okay. And when I do that, then I'm going to find those x-intercepts, and those are my zeros. Those are my answers, my solutions. Okay. So let's try a couple. On the next slide here, it says solve by graphing the related function. So if I look at that first one, 2x squared minus 5 is equal to negative 3. First of all, if I go back to the previous step, remember it said I want to set this equal to 0. So what that means is I'm going to have to get rid of this negative 3 and make it be equal to 0. So that means I want to move it to the other side. And if I'm going to move it to the other side, that means then I'm just adding 3 to both sides. This negative 3 and positive 3 is going to cancel each other out and gives me 0. And then negative 5 plus 3 is negative 2. And 2x squared minus 2 equals 0. Now that I have it equal to 0, we can replace this 0 with a y. Now, for some of you, this looks funny. You don't like that. So remember, we can just flip-flop the sides, and I could type this into Desmo then as y equals 2x squared minus 2. I'm going to show you, though, like, if you typed in this first red one as 2x squared minus 2 equals y, it'll still graph it for you just fine. So now I'm going to pull up my Desmos, and let me show you. So if I put in 2x squared minus 2 equals y, yep, you know why I think it's guys, because I have my caps locks on. Let me try that. Yep, sorry. So if you notice, once I did that, it graphed my parabola. And actually, when I re-click back on it, there's my vertex. But if it was asking me for the answers, my answers would be x equals 1 and x equals negative 1. Because those are my zeros, those 2 points where it crosses the x-axis. So if I go back here and look at the problem, solve by graphing, I would just say my answer is x equals negative 1 and x equals positive 1. Sometimes, like on the state test, they might say x equals and then give you the box, and then you would just say 1 and negative 1 with a comma in between. Okay. So if I look at the next one, if I look at B, you might want to take a minute and try it on your own. But this one's a little different, so if you don't want to try it, that's fine. Pay attention, you can try C on your own. The reason this one's a little different is it's not just a number over here on the left this time in order to get it equal to 0. It's a variable. So in this case, what I'm going to want to do is I'm still moving it. I still need to get it equal to 0. So I'm going to add x squared to both sides. So here in this case, I would then have x squared plus 6x plus 8 is equal to 0. Now this is what I can put, well, after I change it and set it equal to y. So here I would actually have x squared plus 6x plus 8 is equal to y. And that's now what I'm going to put into my Desmos. So if I pull up Desmos, I'm going to change this. And again, I could do y equals x squared plus 6x. I couldn't remember if it was plus or minus. So plus 6x plus 8. There's my parabola. Oops, click back on it and I see my points. Actually, there's my y-intercept. That's not my answer though. Here's my vertex. That's not my answer, but those points could help me graph it as well. Here's my answers. My answer would be x equals -4 and x equals -2. Sometimes those aren't going to turn out as nice, easy whole numbers. Sometimes they'll be decimals, and that's okay. Not everything in real life turns out to be nice, easy whole numbers. So here in this case, I would say that my answer is x equals -4 and x equals -2. So now I definitely would take a minute and try C on your own. Pause your video. Try C on your own and see if you can do it. Hopefully you've now taken a minute and you're back after trying C to see if you got the right answer. So now I'm going to add 4 to both sides. These two cancel out. I'm left with x squared. Guys, I'm sorry. Let's try again. I want to set this equal to 0. So I am going to add 3 to both sides. I apologize. I was thinking about a way that we do it in Algebra 2. So in this case, I would get x squared minus 1 is equal to 0. I want to replace this with y. And so that's what I'm now going to type into my Desmos. My, pulled up the wrong thing. Y equals x squared minus 1. There's my parabola. And I get values again at -1 and +1. So here, x is equal to 1 and x is equal to -1. And there's my answers. Okay. The other thing is if they want you to solve it, and I'm just going to kind of take away here, they might sometimes say, well, and I showed you guys this with the equation the other day. If I had the equation x minus 4 squared equals -3, remember that I could set each one of these equal to y. So I could say y equals x squared minus 4, and I could say y equals -3. Now I just have a system where I'm trying to see where they cross. So if you don't want to do any of that solving about getting it equal to 0, just set each side. So you'll see the parabola changed a little bit. But now when I type in y equals -3, if I look here at where the line and the parabola cross and I look at the x values, you'll notice that my x values here, again, my x value is -1. My x value of that point where they cross is at +1, which is the same that we got before when I was pulling up here when I did it the other way. So there's two different ways you can solve these by graphing. Either get it set equal to 0 and then put it in, see where they cross the x-axis, or just set each one of them equal to y and see where the two things cross. Okay. Now, the last part of this lesson then is our lovely word problems. But again, we're going to use Desmos to our advantage here. Is we're going to create a function. Well, it says create a quadratic function for each problem and then solve it by graphing. The biggest thing of this that I'll tell you guys for the air test is to make sure you understand what the question's asking you for. That's the analysis part. It's making sure the critical thinking, problem solving. We can put it in Desmos all we want, but unless we know what they're looking for, that's the hard part. Okay, so here it's saying I have a squirrel is in a tree holding a chestnut at a height of 46 feet above the ground. It drops the chestnut, which lands on top of a bush that is 36 feet um, below the squirrel. The function h of t equals negative 16t squared plus 46 gives the height in feet of the chestnut as it falls where t is time. So that equation that they gave us here is kind of like thinking about, okay, my squirrel has that chestnut at the top of the tree or somewhere in the tree, and that's where they are at that point. They're 46 feet above the ground. But we want to know, so the first question is, when will the chestnut reach the top of the bush? Okay, so, but they told us in this problem, the top of the bush is 36 feet below the squirrel. So we need to take this 36 and put it as our height. H of t is going to be our height. So now the equation that I'm using is 36 is equal to negative 16t squared plus 46t. And so again, just like we just did on the slides before, you have two ways to solve it. You can either get this equal to 0, or you can set them apart to both two equations, y equals, and see where they cross. I personally think I want to set this equal to 0. I like that method. So if that's negative 36, I'm going to subtract 36, which let's see if this makes sense. Like height of 0 is when it's going to be at the top of the bush. Okay. Um, And so in this case then, this would give me negative 16t squared. Here, it would give me plus 10. And so here, if my squirrel is 46 feet up, but the top of the bush is 36 feet up, that is a difference of 10. The squirrel's 10 feet above the bush. So here in this case then, I'm going to put this into my Desmos. Okay. So I'm going to put in, I'm going to get rid of what we had before. I'm going to put in y equals negative 16t squared, and then it was plus 10. And you'll notice, so let me get rid of my circles from the last parabola. Okay, you'll notice I have a parabola that opens upside down, and this is kind of like this is the squirrel at the top, and then it drops the parabola, or it drops the nut, and it's going to be here, and this is the top of the bush. So in this case, you'll notice that we have two zeros, but if my domain is time, does it make sense that that nut is going to hit at a negative 0.79 seconds? Hopefully you thought to yourself, no, time can't be negative. So even though this is a 0 in our graph, it doesn't make sense in a real life kind of situation. So my only answer would be this 0.791. Okay. So when I go to look here at my graph, my answer is it would be a time of 0.791 seconds is how long it would take that chestnut to hit the top of the bush. Okay. So how about B then? A dolphin jumps out of the water. The quadratic function h of t equals negative 16t squared plus 20t models the dolphin's height above the water in feet after t seconds. How long is the dolphin out of the water? Okay, and how high did the dolphin jump out of the water? Well, we're not dropping anything. We just have this dolphin. It comes up and comes back down. So we're going to put this equation. We're going to make our height 0. Okay, because we want to know when that dolphin, like if this dolphin's jumping, okay, it's starting in the water and it's jumping out of the water, okay, all of this time from here to here is going to be the time the dolphin's out of the water. So I want to know where the dolphin is landing or how much time it takes the dolphin to land there. And so in this case, I'm just typing in to Desmos the negative 16t squared plus 20t. Okay. And you'll notice again, let me get rid of my markings from before. Okay. In this case, you'll notice that this is the dolphin starting. That's the dolphin jumping out of the water. Here, the dolphin's jumping up and comes back down. So if I look at that point there that we just ended at, this is how much time the dolphin's in the water. So the dolphin, or out of the water, the dolphin is out of the water for 1.25 seconds. So how long is the dolphin out of the water? 1.25 seconds. And then the second part of this question, how high did the dolphin jump out of the water? This is realizing that then when I go back and look at my graph, the height, here's 0, 0. So he's still in the water. You have to pretend that this is my water right here. So if this is my water, where am I going to find the height of the dolphin? I'm going to find the height of the dolphin up here at the vertex. And so I'm going to click on my vertex, maybe. Let me close that mark I just made. Sorry, guys. In this case, the height of, there we go. So remember that in this case, my x, or this, is my time. So here, this is my time. Here, my y value is going to be my height. So in this case, that dolphin got to a height of 6.25 feet. Okay. So make sure we understand when these questions are they asking height of 6.25? We have to make sure that we understand, is the question asking for the vertex or is the question asking for our zeros? Okay. As we've done with all of these stations and especially these video lessons, if you have any questions about any part of them along the way, please make sure you get my attention and ask during class. Okay. Have a great day.